we are going to look into a problem in which a number of coplanar forces are acting at a point simultaneously. So to find out the resultant of coplanar forces, concurrent coplanar forces, we have the equation resultant R equal to square root of sigma h square plus sigma v square, where sigma h is the sum of horizontal components of all the forces and the sigma v is sum of vertical components of all the forces, and the inclination of this resultant with respect to the horizontal is calculated using the equation tan inverse sigma v divided by sigma h. So these are the two equations we are going to use. Now let us consider a ring on which the following forces are acting. A 20 kilonewton force is acting horizontally, another 25 kilonewton force is acting at 70 degrees, a 70 kilonewton force is acting at 40 degree with this 25 kilonewton, and another one 30 kilonewton at 50 degree with the 70 kilonewton, and another 40 kilonewton is acting at 40 degree with the horizontal. So these are the forces acting on the ring. The ring is supported like this. So we need to find the resultant of all these forces. For that, we will use this equation R is equal to sigma h square plus sigma v square, where sigma h is the horizontal components of all these forces and sigma v is the vertical components. So let us draw the components of all these forces. For the 20 kilonewton force, there is no need of finding any component because it is acting in the horizontal direction itself. So first force is 20 kilonewton, no vertical component. And for the second one, the components are this is the force. So these are the components. Horizontal component 70 degree, horizontal component is 25 cos 70, and the vertical component is 25 sin 70. For the third force, that is a 70 kilonewton force, it will be like this. So it is at what angle? From the horizontal in this direction, from this horizontal direction it will be at 70 degrees. That is, this total angle will be 70. That is angle of 70 kilonewton from horizontal in this direction, it will be 50 plus, and this will be 20 degree because this is 70, this is 40, totally 110, and plus 50 160, and this total angle should be 180. So 180 minus 160 will give you 20 degrees. So this total angle will be 70. So the force 70 kilonewton is acting at 70 degree with the horizontal, 70 degree with the horizontal. Therefore, the horizontal component will be 70 cos 70, and this is acting from left to right. Therefore, this will be minus. This will be minus, and the vertical component will be 70 sine 70. 70 sine 70. The vertical component will be 70 sine 70. It is positive because it is acting in the upward direction. Then the fourth force, 30 kilonewton, that is this force, is acting at a 20 degree with the horizontal. So the fourth force will be, it will be like this. Degree, and the horizontal component will be 30 cos 20, and this also will be minus, and this is 30 sine 20. The vertical component is positive because it is in the upward direction. And the last force, 40 kilonewton, is acting like this, and its components are, this is 40 degree with the horizontal, therefore this is the horizontal component, and this is the vertical component. The horizontal component will be 40 cos 40, and the vertical component will be 40 sine 40. I will write it on the, so that I can save some space. So this vertical component will be 40 sine 40. 40 sine 40, and this will be minus because it is acting from left to right, and this will also be minus because it is acting in the vertically downward direction. Now we have the components of all the forces. We need to find out sigma h. How to find out sigma h? We need to find the algebraic sum of all the forces acting on this point or on this ring. And these are concurrent forces because it is acting towards the center of that ring. So sigma h, to find out sigma h, we have to add all the horizontal components of the forces algebraically. That means we need to consider the direction, that is sign also. So first force is 20 kilonewton. It is positive. It is acting towards right, 20. Second force is 25 cos 70, acting towards right. So it is positive. Then third force is in the negative direction, that is towards left. So minus 70 cos 70, and next one is also negative, minus 30 cos 20, and last one is also minus 40 cos 40, this force. So when you calculate this, you will get sigma h equal to minus 54.22. Okay, so it will be acting towards left. Then sigma v equal to, that is algebraic sum of vertical components. So the first force is not having any vertical component. If you want, you can write 0 for more understandability. So I'm not writing it. So I'll start with the second force, that is the first component. It will be 25 sine 70. It is positive because acting upwards. Then next force is 70 sine 70. Okay. Third force is also positive, plus 30 sine 20. And the fifth force, last force, is minus 40 sine 40 because it is acting in the downward direction, minus sine 40. So when you calculate this, you will get sigma V equal to 73.82 kilonewton. It is in the upward direction. This is towards left. So 73.82. Now the resultant R equal to square root of how much? 54.22 square plus 73.82 square. We need not worry about minus sign because when it is squared, that will be cancelled. So this will be equal to, R is equal to 91.59 kilonewton. 91.59 kilonewton. And to find out theta, we'll use the equation tan inverse sigma V by sigma H, that is 73.82 divided by 54.22. This will give you theta is equal to 53.7 degrees. 53.7 degrees. So this is the magnitude of the resultant of all these forces, and this is the angle with respect to the horizontal. Now if we draw this as a vector diagram, it will be like this. This is 73.82 and this is 54.22. This is in the plus positive direction, this is in the negative direction. So this will be the resultant 91.59 and at 53.7 degrees. So this will be the final answer.